Hi, everyone. I'm the only one speaking in English. That's because I'm from Portugal, so my castelhano es un poco portuñol. O sea, English for now, but I have a poster, so if you don't understand something, then you can ask me. And actually, the title works much better in Portuguese and Spanish, because then it's a pun, my experience with experiments. But yeah, so my name is Sofia. This is me here in the Nosti, and you're going to see when I moved here. And in that QR code, you can find my website if you have any questions. But yeah, what is my path? I finished my high school, pretty much what you're doing right now, 11 years ago, in that city that is close to Porto in northern Portugal. And then I did a bachelor in physics at the University of Porto. And the bachelor in Portugal takes 3 years, so I finished in 2015. Then I decided to do a master in physics as well in the University of Porto. That lasts for 2 years. And then I also did a PhD in physics at the University of Porto, but this time I also went to London, to Imperial College. And after that, literally 2 days after, I moved here last year in April to work at SIC Nanogune as a postdoc researcher. And last year, I was also awarded one project from the European Union to continue to carry out my research here in Donosti and also in Zurich in Switzerland. I also like to highlight that throughout this path, I did several internships, I worked in several labs, and one of them, because you always ask me stuff like that, people your age, I also worked as a summer student in Switzerland between my bachelor and my master's. So this path can be described by certain sentences, and the first one is that I was actually doing nanostructures when I was your age. And now you ask me, how were you doing that? And well, it's simple because in my old university, they have a summer school of physics for high school students, for people your age. And you see me here in the middle, I don't think the laser pointer works, when I was your age. And what we did was nanotubes for medical applications. And here, for example, you see an image using a scanning electron microscope. And it was a whole week that we spent in the physics department. And well, I felt at home. I felt at home doing physics, talking physics with other people doing that, with other physicists. So I decided to do the bachelor in physics. And my bachelor then can be summarized with car simulations and the bachelor in physics. This is me at the end of the first year. In Portugal, we have a traditional academic costume. And this is me and some of my friends when we finally finished the first year. And during the bachelor, we have something that are extracurricular internships. And that's when I first started doing research. And my research was doing simulations of thermoelectric devices. And thermoelectric devices, you see here, for example, it's another high schooler, and she's generating electricity with her hand. So the thermoelectric effect pretty much converts heat into electricity, and you can apply it for cars, and that's how my bachelor in physics is related to cars. But, and this is at the end of the last year, so when we're finally finishing, me and some of my friends. So, okay, some part is missing, but pretty much what my master's can be summarized is that we actually don't live in a simulation. So throughout my bachelor, I did a lot of simulations, and I like that. But I actually like to go to the lab more. So I decided to do a master in experimental physics, and the topic was topological insulators. And I can explain that better in my poster, but pretty much topological insulators are weird materials that are both a conductor and an insulator of electricity. And this was actually one of the topics of the Nobel Prize in Physics in 2016. So this is me in the clean room. So if we're doing nano stuff, you have to work in a clean room, and I can explain that in my poster. These days, things were not going that well, but that happens. And I have another image of an electron microscopy, so it's pretty much what I was doing already in high school, which is quite cool. And here is my supervisor, because when you do a thesis, then you always are supervised. You always have someone that is older helping you carry out your work. So after that, I decided to do a PhD. And the PhD can be summarized by how do our phones work. Let's say like that, put it like that. And so if you read the title, there's topological insulators there. So I still work with topological insulators. But then I wanted to apply them for spintronics. And spintronics is like you take electronics, but instead of using charge, you spin. Again, I can explain that better in the poster. But very simple, it was already a Nobel Prize in 2007. because, well, it's everywhere. This was discovered in the 80s, 1980s, and in 10 years, you will already find this, which is a hard drive in every computer. And how does this work is that you have these nanostructures, which are the conductor, like, for example, the pencil, and then magnets like the ones you find in your fridge, but tiny, so nano. And what happens is that you end up with two states of resistance, one higher than the other, and then you have a bit, a 0 or a 1. And what we do is, for example, what I wanted to do in my PhD was to use these topological oscillators for stuff like this. And pretty much I was building them like Legos. There's a Lego that was missing. To then, for example, apply them to improve our phones. And this is my defense in March last year. And after that, as you already know, I moved here to do my postdoc. And in my postdoc, I changed to the magic 2D world. And now you ask me, 2D, you're already doing small stuff, even smaller, what's happening? Well, if I show you this image, maybe you've seen somewhere. That's graphene. And graphene, you find it pretty much very easily in a simple pencil. We're back to the pencil. Because a pencil is made of graphite, and graphite is simple 2D sheets of graphene. And what we do, we take something that is very similar to duct tape, and we take the pencil, and we separate. Not as easy as this, but let's say along these lines. And what I want to do, is, this was also a Nobel Prize in 2010 in physics. What I want to do is pretty much the same structure with the Legos like before, but now the Legos are these 2D materials. Because not only we can do this with graphene, we can do this with a lot of other materials. And this can also be the basis of several devices that then can improve our phones. So again, a clean room selfie. This time things were working a bit better, but yeah, we have fun wearing these suits. And here, for example, you see a device of a 2D material. So here you see this is one material that I exfoliated. We call it exfoliation when we use the duct tape. And then these pink things are to measure its electronic properties. And with this, I would like to say